Hi everyone. So let's start. I'm very glad to see so many of you are interested in high availability and disaster recovery. It's a wonderful topic, very important, obviously. So I'm David. I'm a solution architect here at Couchbase. I do solution architect things, which usually involves going to customers and trying to help them, do stuff with Couchbase. And one of those things is making sure they don't lose their data. So let me tell you a bit of a story before we dive into the whole thing, right? So a few months ago, we were doing a POC with a big customer, big company, makes computer chips. Not going to go into which one. So we're doing a POC and everything's going really well. And one day, one of the guys on the dev team calls me and says, we keep losing data nodes. Every few days we'll lose a node and then we have to reinstall it and add it to the cluster. And it's very convenient. Adding nodes to Couchbase is great. Rebalancing is great. It's very nice for us as admins, but it's kind of annoying to lose a node every few days. So I went over there and we looked at why that happens. And indeed, in the log, you can see that the data just disappears from the node, and it's a random node every time. And after a while, we dug into this and we discovered that they've set the data directory to be /tmp. So lesson number one in ensuring high availability is don't put your data in the temporary folder. All right. So now let's talk about actually ensuring high availability and how you can do that. And we have three things I want to talk about in general, right? So we have high availability, and this generally talks about the application side of things and how you can make sure that your application is actually available, because high availability for a database doesn't mean anything. No one actually goes and measures and and congratulates you on having your database be up X amount of time out of the year. It's mostly about your application and making sure your customers can do whatever they want to do with the application, right? And if it happens to be that the database helps with that, that's very good. And the second part is going to be all about disaster recovery and ensuring a higher level of availability, not within a single cluster, but between different clusters. And then finally, we'll talk about a very important subject, which is how not to lose all of your data. As we said, that was rule number one, not putting it in /tmp, but we'll get into other more interesting and important things. All right, so let's talk about how Couchbase actually helps you ensure high availability. And I'm sure some of you have seen this slide or a similar slide. How many here are actually using Couchbase? Why are the rest of you here? But yeah, how many of you are actually using it in production, though? It's about half. All right, that's pretty good. Well, the rest of you are welcome to join us. It's wonderful. All right, that's very good. So we'll get back to that in a bit. Who here actually writes code rather than doing DevOps kind of things? There's a few people. All right, that's pretty good. The rest of you are ops, DevOps, doing things like administration and all that. All right, excellent. Okay, so high availability is a very interesting topic, and it means different things to different people. But in general, I think we can all agree that having your application or whatever it is you're doing with a database work most of the time is desirable, right? It's certainly better than not having it work. And part of that is making sure that your data is actually there when you go and you look for it. So the way Couchbase helps you do that is, well, there's a multitude of ways, but the first is obviously having replicas of your data. I'm sure all of you know that. It's not new. And the way Couchbase handles replica data is at the vBucket level, which means the actual data partition within each bucket is divided into 1024 vBuckets. And for every vBucket, there is one or more possibly replica vBuckets sitting on a different node, because it wouldn't make sense to put the replica on the same node as the master copy. And if a vBucket disappears, the primary vBucket disappears for any reason, then the replica vBucket becomes the new master. So you lose the replica, but you gain your master back, and you can keep talking to that master, right? I'm sure that's not new to most of you. You've been using Couchbase for a while. But this has a lot of very interesting implications, both in terms of what you can expect in availability, and also what you can expect in terms of data consistency and how your application should behave, and whether it's even a good idea in the first place to have your application use replica data. So what happens when you actually write a document to Couchbase Server? I'm sure most of you have seen a version of this diagram in some place. When you go and write a document from your application server to Couchbase, what happens is it goes into the managed cache. First of all, it goes into essentially memcache in memory. And from there, it gets split up into a bunch of queues. There's actually more than that, and we'll get to those. But for the purposes of this discussion right now, one queue goes and eventually persists your change to disk. And another queue goes and sends that replication over to some other machine over the network, where it goes through the similar process, right? It goes into memory, then it goes into a disk queue and gets written to disk, except as part of the replica copy and not the active copy, right? And this makes sense, but there are at least two very odd things about this. First of all, both of those queues are asynchronous, which means you can't actually trust Couchbase to store your data efficiently, or so it would seem, right? Because what happens if you turn off the switch at just that moment, right? When your data is in memory, but not yet on disk and not yet replicated, you will lose that right. So in just a sec, we'll talk about mechanism of how you can avoid that. And also, so if the data is replicated, excellent. But what does that imply in case you want to use that replica data? All right, so that brings us to our first very simple demo. Let's take a look at what we can do with a very simple application with two servers, and if we turn off one of the servers. So this is our demo application. It's very simple. I hope most of you can read JavaScript, and if you can't, well, good for you, because who would want to? But anyway, this application does something very simple. I'm sure all of you can grok it within seconds, right? All we do is get one of 100 documents every 10 milliseconds, right? So during normal operation, this code would have exactly 100 ops per second. It will get a document and obviously do nothing with it. It will just print a dot on the command line. And what happens if we can't get the document? Again, very simple. I'm sure just one glance is enough to see that if you can't get the document, it will go and try to get the replica document. All right, now the first question usually is, why doesn't Couchbase do that automatically? Why would you have to call a special function to get replica document? You guys are lazy. You should do the work for me. That brings us to consistency. So what happens if I persist something to Couchbase? It gets written to the master copy in memory, and then it hasn't yet got copied over to the replica. I turn off the computer. I go and get the replica from the second server. What copy am I going to get? I'm going to get something that's potentially old, right? So because the change technically got persisted, I got a response back saying it got written, but then the change disappeared, and I have an older replica. And this is a major problem which I can't solve for you because it depends on what kind of application you're writing and what you're doing with this data, whether or not it's okay for you to occasionally get a stale result. We'll get to that in just a bit, but let's run this first and see what happens. So let's run this, and obviously, since the server is actually running, everything is hunky-dory, and we're getting a dot every couple of seconds. If we go over to our Couchbase server, we have to log in. And the password is 12345. It is the height of security. And if you ever want to hack any of my Couchbase servers, you'll know what to do. So here we go. We have our data bucket, and as expected, we're getting exactly 100 ops per second. It's very exact because I'm using a very precise timer to count the 10 milliseconds. So now what happens if we turn off one of the nodes, right? Now I haven't shown this. We have, as you can see, two nodes in our Couchbase cluster, right? 10 and 11. So let's go and simulate a failure. All right, so something happens to this node, and this could be any number of things, right? From a network partition to whatever. Someone went and played around with the VM. The server died. It crashed. Something. Right. So as expected, we do see a drop in performance. But let's go and look at the application. As you can see, whenever we get a item from the replica, we print out R, which means two things. One, we're not losing any reads, right? So at least half the reads are getting satisfied from one of the servers, and that's all fine. And the other half are coming out from replicas. Yeah.
It looks like there's a bug in your script where you're incrementing index when you're getting the replica. So you're actually pulling a different document when you're getting the replica.
That might be. And I wasn't pretending to write production quality code when I was doing this demo at 2 a.m. last night. So it's entirely possible that if you want to submit a pull request to my GitHub, I'll happily review it and fix the bug. But I think we all get the point, right? So yes, in production, you should try to get the same document back. That's a good idea. But the concept remains. We get the actual document or we get the replica. There is no interruption in service, right? And we didn't see any exceptions because every request, even though it fails, it actually goes and retries and gets the replica back. And this is the absolute minimum you can possibly do as a lazy developer to ensure high availability, right? And you'd be surprised how many customers I go to and they don't even bother to go this far, which upsets me. But more to the point, this is the absolute minimum and it's very easy to do, right? And in any language you care to name, this would work. And now the question is this a good idea, right? So think about whatever application you're working on, and is this a good idea to go and pretty much automatically go and get the replica instead of throwing out an error? Yeah.
The question is about consistency.
Exactly, that is exactly the question. So how many of you actually work on something where this would be a very bad idea indeed? Anyone think about the applications you actually have?
Yeah, I mean, in some of our cases, this would be spot on, but some of them would be deadly. So.
Exactly so, right? So think about things like, for example, if my bank were to do this, right? You go and you put some money in your bank account, and I don't know of any bank who stores bank records in Couchbase. I'd love for that to happen, but it hasn't happened yet. But if a bank were to be so foolhardy as to put their bank data into Couchbase, this certainly would not be a good idea because you go and you do a transaction, and if you happen to lose the transaction just then, you'll get a stale document which has a different amount of money in it. It might be good for me, it might not be. So all right, but now what do we do to fix this? Because right now it's still running and the cluster is still in an unhealthy state because one of the nodes is down. So we can do one of two things. Obviously we can turn the node back on, and that would be nice. And if that happens, and this is actually a very common scenario because this happens a lot, right? Nodes in Couchbase, as in other systems, don't always go offline for real. Oftentimes it's a false positive because whatever, network hiccup happened or network partition happened, and especially if you're in a virtualized environment, this happens a lot. On Amazon, we do have a lot of false positives where you see a node down where it's not actually down, and if you panic and fail the node over, you're actually doing yourself a disservice because maybe waiting a few seconds would have brought the node back. But here we have one of two things. We can either fail the node over, which means we'll activate the replica that's on the first node. It'll become the primary copy, and all of our documents will now live just on node A, on the first node, and the second node will actually no longer be part of the cluster. Or we can hope that it will actually resolve itself. All right, so let's do the first thing. Actually, now let's resolve it. We'll get back to failing over in just a bit. Yeah.
Before you start the service, can you show the admin console? It must have failed over, right?
It hasn't failed over yet. In order for it to fail over, something has to happen, right? I have to either turn off automatic failover, which actually wouldn't work in this case because I only have 2 nodes. I need to have at least 3. Or I can hit the failover button. But so all the time I've been talking, the cluster has been in an unhealthy state. All right, so let's turn it back on.
But why is the application keep sending requests to this server that's already determined to be down?
The server might be down, but first of all, the application isn't aware of the state of the server. As far as it's concerned, the topology of the cluster is still the same. I haven't performed an action which would change the topology of the cluster. I haven't told it to fail over or remove the node from the cluster. When I do that, the cluster will then go and inform the SDK that the number of nodes in the cluster has changed, and the SDK will know to go to a different server for the same document. But right now, as far as the SDK is concerned, the document still lives on that failed node. So it will first go and try to get it from that node, get an error, and then go and try to get the replica.
That seems quite strange because you shut down the server.
Yes, but the SDK lives in the application. It doesn't know that. It doesn't know why it can't retrieve data from the cluster.
Lose all the socket connections when this server is already shut down?
Yeah, but the node isn't intelligent enough. The SDK isn't smart enough to take this decision on its own, right? The server has to decide what happens with the node.
Why wouldn't you make the SDK smart enough?
It's not easy.
Sending the request to a server that's already known to be closed, those socket connections, right?
Right, so now as we've turned the node back on, you can see that we are not getting replicas anymore, right? And we're back to getting just the actual copies. And that's one of the reasons why we don't automatically decide things in the SDK, because the SDK isn't aware of all the data it needs to know in order to decide whether that node was really down, or it was a network partition, or it's some other reason, right? So if the server decides to fail a node over, it will let the SDK know, and then the SDK will know to do something else. But until the server actually tells the SDK that the cluster topology changed, it's going to assume that what it knows is exactly what it is. All right, so we're back to doing this, and obviously you can keep it running, and you can see that it's all great. So that was the first, it's a very small and very simple demo, but it actually demonstrates a bunch of important things, right? So consistency and what choices you make in consistency, yeah?
So my question was, does the application have, can the application know which replica did it get?
That's a good question. I'll actually start repeating questions in case, so you can actually record that. So the question was, does the application know which replica it got, right? If I have 3 replicas in my bucket, does the application know? But the answer is, well, first of all, no, it doesn't know that. The replicas aren't numbered in any way. Internally, the SDK knows which server it came from, but it's a meaningless distinction, because the important thing is whether it's the active data or a replica. All the replicas are equally potentially inconsistent, right? So it doesn't matter if you got replica number 1 or replica number 3, they're all equally stale as far as the app is concerned, right? Actually, internally, what the SDK does, it does a scatter gather. It goes and sends the request to all replicas, and it uses the first one it gets. So technically, if the master isn't actually down, it might ask for a replica and get the result from the master itself, if it was faster than the rest. This is why you can never know, as soon as you ask for a replica, you can never know if you're getting a consistent result or a stale result. So you have to assume it's stale. Yeah.
So when active is active, active exists and replica is replica.
Yep.
During the time it still sends it to active and replica, but it takes the result from active only, but it doesn't get it to replica.
No, when you ask for just the active, it will only go to the active and get that one, because there's a lot of overhead involved in doing a request to all the replicas and getting a bunch of network data back. So it will be very wasteful. This, by the way, is why it's never more efficient to issue get replicas requests, right? In other databases, for example, oftentimes you increase performance by load balancing across read replicas. That's not how it works in Couchbase. There is no performance difference in whether you read the master copy or the replica. It's the same thing, because the node that holds your replicas also holds its own master data, right? So if you just read more replicas, you're competing with some other master data from some other vBucket. Right, so I have to move on. So we'll get to the question in just a bit. So let's keep going. All right, we got to this part. Now, how does the actual replication happen? Internally, Couchbase uses a protocol called DCP, Data Change Protocol, which maintains a stream of changes between every node and every other node. It also happens to be the same protocol that is used for cross data center application, and we'll get to that in just a bit. And there is a constant stream of data going from the node that holds the active vBucket to every other replica vBucket. It's not 1024 streams at the same time, but they rotate, so effectively the replicas happen very quickly. Now, what happens if you want to ensure that your write is actually durable? Right, I'm sure most of you, a few people at least, are nodding because you know that there's an API for that. But the answer is there's an API for that, like most things in Couchbase. When you're doing the write, you can actually specify that the SDK should wait and not return from the server call until a certain condition has been satisfied. For example, until a certain number of replicas has been created, or a certain number of disk writes have been performed. For example, if you say wait until there is at least 1 disk write, it means that the SDK will actually keep long polling the server until the state of the document is persisted to disk, which means the entire disk queue has been filled and it has written something to disk. This takes a very long time, which is why there's the second durability requirement, wait until a certain number of replicas have been created. Which is what most customers use, because that's a good compromise between latency, waiting a long time for the durability requirement, and also being certain enough that the write isn't going to go away because something happened to the cluster. Right, so waiting for 1 or more replicas waits on the network queue, on the DCP queue between the master and the replica, which works at network speeds, usually single milliseconds, whereas waiting on the disk queue works at disk speeds, usually on the order of full seconds and possibly more, because by default, Couchbase buffers a bunch of disk writes before flushing them to disk. So you can take the chance of potentially not getting your write completely persisted, but usually waiting for at least one replica is good enough to maintain what most people want, which is 5 nines of durability or whatever it is you aim for. It's usually well within your SLA versus against your clients, right? So this is why you the reason it's an API is because it makes no sense to request durability for every write. Not every write is as important as every other write. Right? If you go back to the example of the notional bank, which uses Couchbase for storing my account information, I would certainly hope that they use high durability for writing things, because it's important to remember that my salary got deposited to the account. But if you're just storing session data or something that's actually very transient, it makes no sense to require durability for that, because it's not really that level of importance. And you can select for every write what kind of durability requirements you're actually going to ask. Right? And obviously there's a performance cost associated with that. Now we talked about the failover process, but let's go into that a bit more. As we said, all the data in the vBucket is divided in the bucket in Couchbase is divided into vBuckets, and every active vBucket has a replica on some other node. So when the node goes away, first of all, what happens? Nothing, because as you saw, it keeps being down. But then eventually something happens, which is a failover process. And the failover can be automatic or manual. You can go and hit the failover button, or call a REST API or something like that. Or you can configure failover to be automatic if the node is down for a certain amount of time, 30 seconds or more. Then the cluster will automatically decide to kick that node out of the cluster and actually enable the replicas and turn them into active copies. So what happens is, while you're talking to, let's say, shard, in this case, shard is the same thing as vBucket, number 1 on server 3. If server 3 goes away for any reason, then its replica copies will get promoted to active. And then, this is important, this is the point where the cluster informs all the SDKs that something changed. Before that happens, that was your question, the SDK has no idea that something is wrong, right? As far as it's concerned, it can't find some of the data, but the cluster is still the same. This is the point where the cluster topology changes, and this is the point where it goes back, as far as the application is concerned, goes back to functioning normally. But at this point, your cluster is missing one replica, right? So it's not a healthy cluster. You have to do some extra steps to bring back the cluster to a healthy state, where every document has the right number of replicas. So this is where, what do you have to do? It's not a trick question. I'm sure most of you use Couchbase. What do you have to do to bring the cluster back to health? Rebalance. Excellent. Very good. So yeah. And obviously, you have to pick your timings with rebalance, because rebalance is a very expensive and high load operation, so you might not want to rebalance right away. In fact, if your cluster is under high load, you might actually want to leave it in an unhealthy state until some kind of low time or an off-peak hour, and then rebalance then, right? Because especially if you have more than one replica, you can afford the risk of running with -1 replica until you actually get to a good time to rebalance. So let's take a look at failover in action, right? You can turn this off. So this is the same example, except it doesn't read, it actually writes instead of reading. And it's going to demonstrate two things for us, right? So we're trying to insert a document, again, every 10 milliseconds. So we have 100 ups per second of writes going into our cluster. Now let's turn off. Oh, that's unfortunate. Let's figure this out. There we go. Thank you. All right, so this is the second example. It's exactly the same as the first, except we're doing upsert instead of get, and there's no question of replicas because you can't write to a replica. And we'll talk about why you can't write to a replica in just a moment. So we're writing to this cluster, so obviously logically, but half the writes go to node number 1, but half the writes go to node number 2. Right? If you look at the UI, we'll see that yes, indeed, we're getting pretty much exactly 100 ops, 100 sets per second. Right? And if we look at them per server, then obviously it's about 50 each, as expected. All right, so let's turn one off. And now, as expected, exactly half the writes will fail. All right, so what are our options at this point? Okay, we can't write to a replica. The reason for that is, well, first of all, that's not how the Couchbase architecture works, but why doesn't the Couchbase architecture allow for this? Is because Couchbase is configured to be consistent by default. Pretty much everything in Couchbase is geared towards consistency, where if you write something and Couchbase confirms that you have written it, you will read back exactly the same data you just wrote, right? And you can manually decide to break consistency. For example, with the get replica, this is the reason why there's a separate API for getting from replica rather than doing that in the background transparently to you, because Couchbase doesn't take the decision to break consistency for you. You have to explicitly say, it's okay to get stale data from replica, I'm okay with the inconsistency, right? For writes, there is no such options, right? You can't write to a replica right now. It's somewhere very far down the roadmap in our PM team, but right now it's not allowed, which means that writes in Couchbase are 100% consistent. You can either always write to the master or just not write at all. So at this point, what can you do, right? Well, at some point, a failover will happen, and this will resolve itself because the replicas will become the master, and all your writes will go to node number 1. But until that happens, there is an unavoidable window of time where you can't write, and there's nothing else you can do. So at this point, as a developer, your application has to actually cooperate with the database, right? This is the edge of what we can do with the database in terms of high availability. Couchbase can't help you anymore in this case, right? Your application has to do something to ensure high availability together with Couchbase. So the trivial thing would be to retry, right? If you retry enough times at this point, eventually a failover will happen and writes will actually succeed. I realize it doesn't sound very encouraging, but this is what you have to do. The other option is to use some third location to store your writes temporarily and then drain that into Couchbase when that becomes possible. Usually the third location is very simple. It's another Couchbase cluster with replication with XDCR configured to the main cluster. And we'll get to XDCR in just a moment. Or it can be anything you want, a queue, some kind of offline storage, anything at all, where you can keep the write. It's not always possible, right? Some writes have to get written immediately, otherwise it just doesn't matter anymore, in which case you lose high availability, right? Because in this case, you generally have to decide between availability and consistency, and Couchbase always falls on the side of consistency. It makes it much easier to develop code with Couchbase, because writing code to a consistent model is much simpler and much easier to reason about versus writing code with a database that's always inconsistent by default, right? Because this case, you have to just handle an error which happens once every so often, whereas if your database allows writing to a replica, it means it's always inconsistent, so you have to handle the inconsistency 100% of the time. All right, so it's better to write some special code once, that happens once every so often, than always have to deal with the inconsistency for every write. So now let's actually fix this. Let's fail over the node. Now if I had more than 2 nodes for my demo, obviously this would happen automatically. And for those of you who don't know, it's over here, auto failover configuration. Now the minimum timeout you can set here is 30 seconds. We're actually working for the next major Couchbase release to bring that down. Don't quote me on the number, but the target we're talking about is about 5 seconds for failover as the minimum timeout. It's a major feature that is often requested by customers. So sometime in the next major release, that's going to come down to about 5 seconds. Maybe less, maybe more, again, but this is where we're aiming. But either way, there is that time window where the node is down before failover happens. The reason, by the way, why we don't just failover immediately, right, within the same second, is because false positives are much more expensive than false negatives, right? So if it's a false positive and you go and you do a failover and you lose half of your data and then you have to rebalance the entire cluster, that's much more expensive than having your application deal with unavailability for 5 seconds or 30 seconds in this case. All right, so let's fail it over. Yes, confirm failover. And as soon as we do that, as you can see down below, the application goes back to normal. We get 100 writes per second now. Let's actually demonstrate that we are indeed. And as you can see, we went from 50 writes per second to 100 writes per second because in that instance where I failed over the node, the SDK got an update that the cluster topology changed, so all writes are now going to node number something 10. All right. So again, this is a very simple solution, right? And if I had to write this code, doing a retry is pretty trivial, and it gives you just enough availability to fit within your SLA, right? Because availability is not just an abstract concept. Usually when you write an application which is used by clients, you have some well-defined SLA saying, you have to be available 5 nines or something, right? A certain number of time throughout the year. And this is, we're now well within that SLA because waiting 30 seconds to retry is usually good enough. All right, so let's stop this, and what we're going to do is start talking about XDCR. So let's actually turn this cluster into 2 clusters, right? Since we had one node and we failed one over, that means we have a free node which we can now reuse as a second cluster. So let's rebalance this one to say that it's all right and the failover is correct, and then we'll go to that second node and turn that into a second cluster for us. It'll come back up in a second because after being failed over, it actually restarts. So we'll give it a second to restart. Oh, no, it will not because I turned it off. So we would be waiting for a very long time. All right, so let's start it, and then the node will actually work and we can repurpose it. There we go. So now it's actually going to restart and we'll have a second cluster. So there we go, it comes back as a new node because we failed it over. We won't waste too much time setting it up. We'll just do next, next, next. Yeah, all right. It's a very small VM. All right, so next, 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 and we'll have our second cluster. We'll even give it a name. Yes and no. There we go. Now let's go and give it a name. By the way, this setting, we'll call it cluster 2. This is the only thing this setting does, by the way. It's not reflected anywhere else. The cluster name is used by exactly one JavaScript function in the entire code base of Couchbase. So just so we know, this is cluster number 2, and this one we'll call it cluster number 1. There we go, cluster 1. Perfect. So let's we'll go back to the presentation, and we'll get back to here in just a moment. All right. So before we switch to talking about XDCR, just one last thing. If you don't do anything, your replicas get spread around the cluster randomly. But oftentimes it's not a good idea to have all of your replicas of a single document within the same physical fault domain. This is where rack awareness comes in. So in case any of you weren't aware of this, this is a very important feature. It amazes me the number of customers who still don't use that for some reason. Rack awareness simply means that you can define groups of servers which are within the same fault domain, and Couchbase will then ensure that each one has one replica, right? So instead of having, let's say, both blue replicas in the same rack, if you define servers 1, 2, and 5 as part of the same fault domain, it will actually ensure that the replicas are spread out between the different server groups, right? So that if an entire rack falls or goes away, you still have at least one replica in a second rack or a second availability zone in Amazon, right? So this is a small feature, but it's very, very important, and if you're not using it right now, you definitely should be. All right, so let's talk about disaster recovery at a higher level. And again, there is a very unclear line between high availability and disaster recovery because usually people don't really think of disaster recovery as, oh no, a meteor is going to hit our data center, right? Because usually they don't. But generally speaking, it just means I want to make sure that not only is my one data center safe, I want to make sure the application is survivable and robust enough to survive a whole data center failing. This is usually what they mean by disaster recovery. Hardly anyone really means that, okay, there's going to be a war and what's going to happen to my application if there's a war, right? So disaster recovery generally talks about what happens if we lose a data center and how long is it going to take us to recover? What's the way to minimize time to recovery from the moment of failure of an entire cluster, right? Because if one node fails, it's fine. We have replication for that, or as many nodes as we have replicas can fail and it's still fine. But as soon as enough nodes fail, we lose availability. So this is where XDCR, the cross data center replication in Couchbase, comes in. Again, all of you know this. It's not a new feature. But one of the cooler things coming up in the next release, in the developer preview of 4.6 that just came out, we now have a last write wins resolution for conflicts in XDCR, which allows us to do a lot of cool stuff, right? So one of the things customers have been doing for quite a while now is maintaining two connections to two clusters and then doing what's called manual failover between clusters, right? So you decide that this cluster is no good, now I'm going to start writing to that cluster. And the main issue with that is the same problem we were talking about earlier of consistency versus availability, right? Because if you've been writing to one cluster this whole time, and then you suddenly start writing to another cluster, you're never sure how much of your writes have actually reached the second cluster before you start writing there. So you might be actually overwriting some data, or you might be missing data in that cluster because XDCR is slow enough, because it works at network speeds and presumably between different geographical locations, that you can never be sure that all of your writes have actually reached the other server. So now we will actually have proper last write wins conflict resolution. You will be able to do things like, for example, make sure that all my writes from cluster A have actually reached cluster B. And if I'm going to go and change a document in cluster B, I can now ask will be able to ask the SDK not to overwrite this change with an older change if it hasn't reached that cluster yet. Right, so there's going to be a bunch of really cool stuff, and it will actually be supported in the SDK. One of the things on the roadmap for the SDK team is to actually be able to support multiple connections. So you'll be able to provide the SDK with the IP addresses of two clusters and some set of parameters which tells the SDK when to switch over from one to the other. You won't have to write this manually or maintain two connections yourself. The SDK will actually do that for you. But until that happens, let's look at a very small demo of how you can actually do cluster level failover. So what happens when you actually write something with XDCR enabled? This is the same slide we had earlier, except now we can also see the XDCR queue. And the XDCR queue is obviously also asynchronous. So when you write something to Couchbase, it will go to memcache, it will go to disk, it will go to a replica, and at the same time, it will go into yet a third queue which gets sent over the network to the other cluster with XDCR. The difference is the XDCR queue buffers a lot more data. It buffers bigger chunks, so it's not as immediate. It's not a single millisecond. It's usually on the order of a few milliseconds. And also, there's no way currently to check whether the XDCR write has actually reached the other side. Right? The best you can do right now is just poll the other cluster manually yourself. With 4.6 and the last write wins, we'll actually be able to do something more advanced, like actually having durability requirements over XDCR. And this is coming. The SDK team are talking about how to implement this right now. Yeah.
You mentioned something about the replica, the number of you can define in the rack. So that topology, where do we define? Is this in the rack, something in properties file? I mean, how does we know that?
It's in the UI. Let me just show you. It's very easy to show. If you look at the server nodes, there's a button here called Server Groups. And this is where you can, define the rack topology, right? So you can have server groups. Let's create a group, we'll call it rack 2. And we can just drag nodes from one to the other and assign them to what different nodes are. And when we save this requires a rebalance, because it will actually move physical vbucket copies from one node to the other, right? So as I said, this is a very simple feature, and you should be using it right now, whether you're on Amazon and you have availability zones or physical racks. If you're not using it yet, start using it. I've seen this save a lot of data for customers, so it's important to use. Right?
That, if the nodes are on the same
Well, no, that's not going to help you, right? And if you're within the same availability zones, that feature is not going to save you. But yeah, but most people are, a lot of our customers are in virtualized environments where you actually have availability zones. And if you're in a physical environment, then you probably have some kind of racks or some kind of fault domains you can define. So definitely do that. All right, so going back to that, we have our two clusters. Let's create XDCR between the two of them. So in case you haven't seen it, this is how you do it, cluster 2. And now we'll create replication from the default bucket to the default bucket on the other cluster. That's all it takes. So we have replication running in one direction from this cluster to the next. We can actually check that it is indeed running. All right, we have outbound XDCR. It had nothing, and then it went up to 100% completion. We're not writing anything yet to the cluster, so it's now synced, right? All the documents from cluster 1 are in cluster 2. So what can we do in order to ensure availability across those two clusters? Again, very simple example, not production quality. If you find any bugs, feel free to submit bug reports. It does a very simple thing, right? We open two connections. This won't actually be necessary. As I said, in the future iteration of the SDK, you'll be able to just open the same connection essentially to both clusters. But right now we have two cluster connections with bucket 1 and bucket 2. And we have a very simple heuristic. As soon as we get at least one error writing to cluster 1, we stop writing to cluster 1, we start writing to cluster 2. Right? This code is buggy in all sorts of ways, logical bugs, right? Because it's not consistent and it's going to be a problem. But first of all, let's run this and see what happens. Right, so right now, obviously, it's writing successfully, very good. We can see 100 ops per second, and we also see 100 ops per second getting replicated to the other cluster. So now if we kill one of the clusters, let's go and actually stop server number 1. As expected, we'll see a bunch of errors, and then the errors should disappear, right? We shouldn't have seen more than one error, but I'm lazy, so I didn't actually catch all of them. But now the errors have gone away because it switched from bucket 1 to bucket 2, and it continues to write to the second cluster, right? Now, this has a bunch of very odd implications about consistency, right? Because this cluster is down, but as you can see, this cluster is now getting all the writes. Indeed, you can see 100 ops per second right here. So what happened to the copies of the documents which were in flight in XDCR? We lost those writes. What happens now if I reconnect XDCR? We're going to end up with two separate copies. One cluster will have its own copy, and the other cluster will have its own copy, because the way current XDCR conflict resolution works is by whoever has the most revisions, right? Right now, cluster 2 has the most revisions, but if I were to write another document to cluster 1, they'll each have different revisions, and there is no replication going back from cluster 2 to cluster 1. So we'll actually have two separate branches of our changes, right? And this is actually very difficult to deal with, which is why I'm very happy we're about to have last write wins resolution, which makes it just much easier to reason about conflict resolutions in XDCR. And if you haven't checked out Couchbase 4.6, you should. It's on the website, the developer preview right now. So give that a go. But right now, what does this imply about consistency and how you're going to deal with this situation in your code? Essentially, it comes down to the choice of what do you prefer, harvest versus yield. How many of you are familiar with the concept? Does anyone know what the cap theorem is? Everyone knows cap theorem, right? Used to be very popular to argue about it on blogs. Consistency versus availability, all that stuff. But before we had cap theorem to argue about, we had two somewhat older concepts to argue about, which are harvest and yield. Where yield is defined as the percentage chance of you getting any kind of response from a server request, and harvest is defined by how much of your data will actually be in the response, or what the quality of response is, right? So the question is, do you prefer to get any response from the server, even, for example, it's missing some documents? Let's say I want to read 100 documents from the server, and some of the server is unavailable. Would I prefer to just get an error and get no documents, but I get an error consistently, and either I get all 100 or none? Or would I prefer to get 99 of those 100 documents? right? And this is obviously different for different applications. So for some applications, it's a trade-off which you can choose to one side. You can choose the side of more yield, which means you get more answers, and some of them will be partial answers. Or you can optimize towards harvest, which means if you get an answer at all, you ensure that you get the other way around, sorry, optimize towards yield. And if you optimize towards harvest, then you might get partial answers, but at least you will get any kind of answer, right? And this really depends on the kind of application you're developing or maintaining, and this is a choice you make while you're designing your application and before you start writing your code, because you're going to have to design everything all around this one choice. What happens if the server doesn't respond with what I'm trying to do, right? Do I go to another server and ask that and maybe get partial results, or do I just throw an error to the user? And this is not something I can actually answer for you, obviously. You have to keep this in mind when you're designing your high availability and disaster recovery mechanism, right? So again, I've been focusing very much on code in this case because the operational side of this is fairly straightforward with one major exception. So let's go back to this. There is one thing I haven't mentioned yet, and it's pretty important. And usually, when people talk about disaster recovery, there's one thing they always forget. Now, I asked earlier how many people have Couchbase in production. Was most of you. How many of the people here who have Couchbase in production have a well-defined backup policy, nightly backups? It's like 5, 6 people, 7 people. Of the 20 at least who raised the hand earlier. So what did the rest of you do? Do you just like living dangerously? So yeah, backups are important, and backups are really important because they protect you from things which all the other stuff I talked about doesn't protect you, right? So backups aren't meant to protect you from power outages or network problems. Backups are meant to protect you mainly against one thing: developers who in the middle of the night like to click the flush button on Couchbase. And as we all know, we've been conditioned by the internet to not read warning messages. So when you go and you click the flush button and it says yes or no, usually people click yes. I've seen this happen. Luckily, did you guys have a backup?
Yes.
See, there we go. Backups are important. Yes?
So, if you look at the diagram, first is the data entities.
Right?
I mean, if you delete it, well, there's nothing you can do about it, but let's say there's a power outage and they bring back up.
Yeah.
If you restart your server, then everything will be stored?
Everything that was actually written, so all the changes that have gone through the disk queue and actually got flushed to disk, they will come back up. Anything that was actually in flight, so in the middle of being replicated or in the middle of being written to disk, that will be gone. Which is why if you're writing important information, it's important to use the durability requirement, and because that way the application doesn't assume that the write has succeeded until it has actually been persisted to disk or at least replicated, right?
There is a trade-off on that. Once your durability, once you write into disk versus writing into the memory, there is performance.
Waiting for a disk write is obviously very expensive in terms of latency. But if it's important data, then you should do that. And if it's reasonably important data, usually waiting for a replica is good enough, right? So backups. I don't know how many of you have actually upgraded to Couchbase 4.5. Probably not everyone, but Couchbase 4.5 has, I think, one of the cooler things we've done so far, which is the new backup manager. How many have actually tried the new enterprise backup manager? Just one. All right, excellent. So Couchbase now comes with a proper backup tool which relies on the DCP protocol, and it's very fast and it doesn't eat all of your memory on the server, which is a welcome change. But mostly what it does, it's built on the concept of repositories, right? So you create a backup repository and then you incrementally add to that, and it can actually now back up both indexes and view definitions and XDCR definitions and pretty much everything you have in the cluster. So it's a full backup solution. It's also very easy to use. So let's do a very quick demo before I finish this talk. So CB backup. Yeah. Yeah.
So backup, when you do backup, one of the things we notice, it invalidates some of the caching, the way you are doing the caching. The items
Right.
in the bucket which are in the cache, during the backup, when you run it across those nodes, it takes the other items into the cache, and that's how it does just leave.
Yeah.
Is it gonna be
This doesn't do that anymore because it uses DCP, which streams the data without actually affecting the cache. So that's one of the benefits of actually using CB Backup Manager. Also, you can actually, when you're doing backup here, you can specify the number of threads doing backups in parallel, so you can finish backupping up much faster, obviously trading off performance with that. So we start by defining a backup repository. And as you can see, I'm violating the first rule of high availability, and I'm putting the backup in /tmp. Let's call it demo 2 because there's a demo 1 in there. So if we go into backup, we'll see that we have a demo folder here. So let's go into demo, and here we have just the metadata about what we're about to back up. So now if we write a backup to that, we need to tell it which repo it is. It's a demo repo, archive /tmp backup, right? And then user name, the super secure password, and host is obviously localhost, right? What did I miss? Oh. All right, it's not localhost. It's there we go. No? Oh yeah, it's down now. So let's back up the other one. Excellent. See, this one is actually up. All right, so it's very fast, and well, obviously we're only backing up 100 items, but even if it was much more, it would actually back up very quickly. And if we look in the backup folder right now, we have not just the data itself, but we also have all the index definitions and all the other things that come here. So as you can see, we have views, GSI index, full text indexes, everything is backed up as well as the data. And to restore, obviously, we do the other way around. This is actually very safe to run with very small increments. So you can run this every hour, every 10 minutes, it doesn't matter how often. You'll end up with a lot of incremental backups in your backup folder. And CB Backup Manager also comes with a command to compact your backup. So you can tell it to merge all the incremental backups into one single global backup. Yeah?
Is there some way to control how much IOPS this uses? Because I know that's been a challenge we've got coming out of the last talk.
Yes, but only by actually setting, telling how many threads to use, right? And it uses 1 by default, but you can tell it how many threads to use, and it will throttle down or throttle up accordingly. But that's pretty much it, right? There's no more throttle. All right. So this pretty much concludes what I wanted to show, and please, those of you who said you have Couchbase in production and didn't raise your hand for backups, go and build a cron job tonight, which will do backup. And I'm happy to answer questions if you have any. I will be over here. Otherwise, thank you very much for coming, and hope you enjoyed the rest of the conference.